Thank you for asking me to speak today. There's a lot to say about electric vehicles and a lot of opinions out there on the subject. I'm not going to really tackle exactly where the energy is going to come from for electric vehicles, although I will touch on it. The work that we're doing at OVO assumes that people will solve the generation challenge, although we'll talk a little bit about it. We're focusing a lot more on how that energy is delivered to the devices and at what time and through what means that delivery is controlled. And I'll be telling you a little bit about the technology that we've been developing and have recently announced, yesterday in fact, on the subject. So I just want to start with a statistic which I'm sure many of you in this room will know. But every single day in the United Kingdom, 124 million litres of road fuel are consumed. It's more than 2 litres for every member of the population. That adds up to 45 billion litres every single year. And in calorific terms, that is an enormous amount of energy. If you assume, which I do, that by a certain time in the future, and their opinions differ on this, this liquid fuel will be translated into electrical fuel to drive our then electric transportation system, you can start to get an understanding of what a massive transition we're talking about. And we're not really just talking about a technical engineering transition, we're talking about a complete revolution in the way that our economies are structured and the way that we consume and manage our energy. It's part of the reason why we're starting to see some very interesting activity from the oil majors into the electrical transportation sector and into the electrical retail sector in general, such as the acquisition by Shell of First Utility and New Motion, and there are many other examples of this transition. So OVO sees this future, believes that this will happen, believes for a couple of reasons I'll talk about in a second that it needs to happen, but the scale is phenomenal. So why will this happen? And there are a few reasons. A lot of you will know about the 3, 4, 5 Ds of the energy transition. I'm just going to talk about a few of them. The most pressing one in terms of OVO's work is around decarbonization. And most people, and certainly legislation, tells us that we will have to decarbonize our heating systems in the UK and our transportation systems. And that represents an enormous change. The electrification of heat, the electrification of transport needs to be carried out in order to decarbonize. So that's a driver. On the flip side, electric vehicles actually represent an opportunity. So we often read articles in the newspaper about the challenge of electrification and what a problem it is, how much trouble it's going to cause, and how all of our lives are going to be disrupted by the power system being crashed by the electrification of transportation. But there is another way of looking at it, and the way that we look at it at OVO is as an opportunity. Here's some visualizations of the potential of electric vehicles. So taking Hinkley Point C on the left here, you'll see that's going to be about 3.2 gigawatts of power output from Hinkley Point C if it ever gets built. And then if you imagine one of the scenarios that the National Grid anticipates of 2.5 million electric vehicles on the UK roads, if you were to equip those electric vehicles for vehicle-to-grid capabilities, they would represent a power capacity of 12 gigawatts. If you take a slightly more aggressive scenario, the electric vehicle capacity could represent 25 gigawatts. In other words, a significant order of magnitude more power capacity available from power potential available from electric vehicles than one brand new nuclear power station. And so we see this opportunity, and we're working hard to unlock it. So we all know, or I think we know, that the electricity system is changing, and we're moving from a centralized electrical infrastructure where you have large thermal generators, a central transmission network, local networks, and then consumption at household or commercial level. We're starting to see a completely new model of the electrical system infrastructure to a distributed system, not just of how we consume the energy, but where it is generated. And we see this developing in time and being necessary for the grid of the future. All of this means that we'll see the electrification and decarbonation across all these different sectors. Now, when you start to imagine that this future, you essentially have two options in your infrastructure. You can either reinforce your local and national transmission infrastructure, or you can make it more intelligent. And OVO's view is that we should make these things more intelligent. We should make our demand side response significantly more important part of our energy system, and stop just trying to match supply with demand in real time, all the time, in terms of at a generation level. So how do you do this? If you imagine a future system, this is a slide, I said I wasn't really going to talk about this, but just quickly on where this energy will come from. I understand that there's a long conversation around this, around whether this potential is realizable and at what cost, but essentially we can power our energy system using renewables. There is the potential to do that, and over time, if a real price is attributed to carbon, this will almost certainly happen. So what are we doing? How are we creating this intelligent system? We have announced yesterday, or unveiled yesterday, a platform, an intelligent energy management platform called VCharge, whose mission is to be able to control, to enable a 100% renewable energy on the grid by changing the control architecture of the grid, by moving from essentially a very sophisticated and talented team controlling with a few dials exactly how much energy our power stations are putting out in order to match demand on that grid, and with some large-scale demand-side response. We're imagining a system whereby the demand-side response and the entire energy system is managed at a device level. This essentially means millions of small-scale energy devices being controlled in real time in order to offer storage to the grid, storage services to the grid, so that we can store our renewable energy when it's been generated, and then we can pass it back to the grid when we need it. So here's a diagram of the VCharge sort of architecture, but clearly it starts with your loads. So we have a variety of different significant energy storage devices at the household level, such as electric vehicles, electric storage heaters, and household batteries. All of those loads need to be controlled in real time with very high speeds, responding to a variety of signals from an intelligence layer, and responding to that intelligence layer needs to respond to inputs from things like weather data, price signals on the grid. And that will tell this electric vehicle whether to slow down its charging or speed up its charging. That will tell this battery over here in this home whether to charge the battery or to discharge the battery. And that is the system that we are building at OVO. Now, in order to make that system possible, and I'm sure there are a lot of questions on this exactly, you need a variety of other pieces of the jigsaw in place. And this is something that we've been working hard on at OVO to deliver. But you need to have data, you need to have customer engagement, and you need to have innovative technological solutions. You also need to have the ability to trade that energy intelligently, and you need to create intelligent algorithms to be able to predict when the energy may or may not be needed. And all of those things come together in the technology that we're developing in order to be able to balance the grid in a new, distributed, decentralized, and decarbonized way. Just like to finish by telling you about what we're actually doing apart from VCharge. Yesterday we announced a variety of household-level, small-scale energy storage devices which will be launching into UK homes this year, this summer and autumn. We announced a home energy storage device, a battery not dissimilar to the Tesla Powerwall. We announced an OVO a smart charger for charging electric vehicles at a variable, modulatable rate of charge. And most excitingly of all, we announced the world's first widely available vehicle-to-grid charger for domestic customers. This will allow people who own Nissan Leafs or ENV200s, which is another Nissan vehicle, to not only charge their vehicle in a smart way, but to discharge their vehicle back into the grid at peak times and other times where we will pay them to export energy into the grid in order to offer balancing services, frequency services, and all sorts of other services to the grid to allow us to realize our vision of the future. Thank you very much.